Hi, welcome to our chemistry lesson today. We have a few things that we need to do. We need to answer the attendance question, complete assignment 10. We're going to work on the equilibrium tab on the simulation that we had completed for assignment 5. And I'm going to ask you to watch some video clips on Le Chatelier. For assignment number 10, if you are having some difficulty with it, go back and review 1, 2, and 3. Also, you can click this linked worksheet. The linked worksheet is going to help us with the equilibrium tab. It's going to remind us. I had attached this worksheet once before, and it went over how to use the simulation for experiment 1. We're going to be doing a little bit more today. But it also had on page 4 information about surface area. On page 5, information about concentration. Page 6 was about pressure. Page 7 was about temperature. Page 8 was about a catalyst. And that can really help you complete that assignment 10. I am also going to put up an extra worksheet here. This is an optional worksheet if you would like to have some more information and if you'd like to work a little bit more with the equilibrium constant. This will actually show us how to use the quadratic formula to solve for the equilibrium constant, especially if you've been studying that quadratic formula in math and you wanted to know where it's applied, you could work on this. I would hope that my honors class would go ahead and do these questions on their own, but it is not required. Now, I'm going to go ahead and take a look at the equilibrium tab on the simulation. So we had worked on this simulation once before. It looked just like this, but this time we're going to work on equilibrium. So I'm going to click that tab and I'm going to go to this. It looks very familiar. But this time there's a spot for A turning into B, but also B turning into A. So I'm going to go ahead. I'm going to just pick 50%. And for the other one, I'm going to go ahead and let's say I pick 20%. So if I have 100 molecules of A and 50% of them are going to change, I'll enter the number 50. And if I have 0 molecules of B and 20% of them are going to change, 20% of 0 is 0. Now I'm going to do it again. 50% of 50 happens to be 25. And 20% of 50 is 10. Now, something really interesting happened here in the math. Not only did I subtract the 25, but I added the 10 to the B because some of the B's are converting back. And then in the B, I added the 25 and I subtracted the 10 because some are converting back. So now I have to do 50% of 35. Is it 17 or 18? Could be 18. Let's see. I guess it's 18. I would get out a calculator and I'm going to do 20% of 65, which I think is like 13. There we go. Oops. 13. Perfect. Now I'm going to do 50% of 30. That's 15. And I've got to do 20% of 70. All right, now I'm going to keep going. I'm going to do about 50% of, and you want to continue. You're going to go ahead and do this. Try some different percentages and work that out. And then we'll discuss how these lines work out next class. What you'll notice is depending on the percentages you picked, these lines may be the reactants lower or the reactants higher than the product. And that is called the position of equilibrium. They're still at equilibrium because the lines are parallel. The amount of reactants turning into products and the amount of products turning into reactants are equal, but the position is different depending on the rate. Le Chatelier's principle that we're going to be working on talks about when a stress is added, how it changes that position of equilibrium. We're going to go over this worksheet right here next class, which talks about equilibrium and Le Chatelier's principle and the three different stressors: concentration, temperature, and pressure. It's not as difficult as this worksheet makes it look. So I'm going to ask you guys to work on watching some of these videos to get yourself started. This one is about 4 minutes or so. I did put a slide up here that gives you some notes so you know what they're asking you in the video clip. This one here is about 4 or 5 minutes. You know, I like Professor Dave. I did put an extra slide up here about exothermic and endothermic, because how the temperature affects it depends on whether heat is with the products or heat is with the reactants. And then finally, I've put up a video clip that ties it all back to our original phenomena. So I'd like you to watch those 3 videos. So again, answer the attendance question, complete the assignment 10, try that equilibrium tab, and we can discuss it at our next Google Meet, and make sure you watch all 3 of the Le Chatelier's videos. And that should be it for today. Good luck, guys.